Before we get into Visual Basic, we're going to discuss the components of a computer system. Now, we've already mentioned some of this in CS 121 and Information Systems 101, but I think it's worth taking a little bit of time just to review the main components of a computer system. That way you have an idea of how all these things are interacting with each other whenever you actually run a program in Visual Basic. So we have our central processing unit, or what's called the CPU. We have our main memory, which stores information in the computer system. We have storage devices to store different files. We have input devices, and then we also have output devices. Now, the central processing unit is also known as the CPU. In fact, most people just say CPU and not central processing unit. You can think of the CPU as the brain of the computer. It does pretty much all of the main work of the system. It does all the computations. This is actually the single most expensive piece of hardware. I mean, there are a lot of parts that are very expensive, like video cards. Video cards are actually getting pretty expensive now, but CPUs are still very, very expensive, not just in terms of price, but in terms of the value of the system. Well, without a CPU, your computer can't do anything. It's not going to work. So it's a very critical component of the system. Now, if we have more powerful CPUs, it means our computer is faster. So it can actually do more computations. It can do them more quickly. So we hear about these different types of CPUs like dual core and quad core, which means there's these different cores in there that each can be treated as an individual CPU. So that allows us to do more instructions, do more computations at any given time. They're also starting to become faster, which means it takes less time to complete a particular step. So that means that you can complete more steps within a period of time. So I mean, a lot of people who play games like to get very powerful CPUs so they can do instructions very, very quickly, or their games can run very smoothly without any lag or any frames per second issues. But if we get more powerful CPUs, that means we have a more powerful system. And this is, like I said, where we have our arithmetic and logical operations are done here. All the computations are done with the CPU. Any type of program that runs has to go through the CPU in order to take instructions and do stuff with it before moving on to the next step. But the CPU handles every single instruction for a program. The main memory is also known as random access memory, or RAM. Most people just call it RAM. And this is actually directly connected to the CPU. So the idea with the RAM is whenever we are to run a program, it has to be loaded into the RAM or the main memory before we can execute it. So if you take your normal program and you say you're going to run it, it's first loaded to the main memory, and then the instructions are sent to the CPU. It executes any instructions, and anything that is supposed to be stored goes back to the main memory. So not only do programs have to go through the main memory, but all the data has to be brought into the main memory before the program can make any changes to it. So for example, if you have a file and you want to make changes to it, it has to be loaded to the main memory first, and then data gets sent out and back and forth between the CPU and the file in the memory, and then that file gets sent back to wherever you have it stored. So everything has to go through the main memory before you can actually do anything with it. We can think of this main memory, this RAM, as temporary storage. So it's not something that permanently stores things. It's only there just whenever we need to do instructions with the CPU. So I mean, in fact, for most machines, they could have like 1 GB, 2 GB, maybe even up to 4 GB of RAM. Some that have more powerful machines may go up to 8 or even 16 GB of RAM. I've heard of some people going up to 24 or 32. I don't know why you would need 32 GB of RAM right now, but sure, you can do that if you get powerful enough memory sticks. But this is just temporary storage. So things get loaded in there, and the reason why it's temporary storage is whenever the computer actually shuts down, everything in the RAM is completely wiped. It's not there. So if you boot back your machine and you had something in the main memory, it's completely gone. Back in the old days, whenever you wrote, maybe working on a Word file, this has actually happened to me before, I'd be in the middle of typing a paper and the power would go out. And then when I get back on, I would find that everything that I wrote was gone because I never saved it. Now, fortunately, things like with Office has gotten a little bit better where it kind of does this auto save pretty frequently, so you can recover some stuff even though if you forgot to save. But a long time ago, that wasn't the case. Anything that was in RAM, if you didn't save it, it was gone when you came back. So that's just one thing to keep in mind, that with the RAM and main memory, it is only temporary storage. So the next question to ask is, how is our main memory actually laid out? Well, it's arranged as this ordered sequence of cells, and we call this memory cells. So each cell within this arrangement has a unique location and the contents of it. So this location is called an address. So let me give you an example. So here's something that looks kind of like how we can visualize our main memory. So we would have the set of contents that can have all sorts of stuff, and we have this collection of cells over here. So we have all these cells right here. And then next to it, we have these addresses. So each cell would have a unique address. Now, in this example, we have address 0 to 99. Realistically, we'd have a lot more addresses. The larger your RAM size, the more memory addresses. So if you have 8 gigabytes of RAM, you're going to have more addresses than if you had 2 gigabytes of RAM. But each cell would have some form of data, and there would be some unique address that corresponds to that particular cell. So the contents of a cell can be either instructions or it could be data. So for example, if we had some program and we were to load it into our memory, we would use a range of addresses to store all the instructions of that program. And each instruction would be stored in a separate cell which has its own unique address. That way when we execute the program, we would go to the first address of that program. That would be the first instruction. We would load that to the CPU. We would perform that instruction. And then we would have some mechanisms that allow us to go to the next address of where the next instruction is. And we just keep repeating this until we get to the end of the program. Now, how is everything stored in here? We see in the contents we have like numbers and data and instructions, but it's really being stored as a sequence of zeros and ones. So these are the binary numbers, and we've talked about this before in other classes, but we have this sequence of zeros and ones. So for example, we could have something like 001, 00110. That would be stored in a particular cell. That could be some value, some data. It could be an instruction that says like fetch this instruction or add two values of addresses and combine them and do all sorts of stuff. But we have these zeros and ones that represent our instructions and our data in a particular memory cell. As we've already said, if we have something in main memory and we lose power, well, we just lost everything that's in that main memory. So it would be good if we had another place to store stuff. We need to have it in some other type of storage device that's on a more permanent basis or more of a longer term type storage device. And we have those devices. Those are called secondary storage. Now, so these are devices that are directly connected to the computer in order to transfer data. And what's nice about these devices is if the power goes out, we don't lose any of the data in these devices. And you've already worked with several of these before. So just to give some examples, we have hard disks. So these would be like the hard drives that are connected to your computer, floppy disks, although those aren't really used as much anymore, but they still exist. Flash memory, so that's like with USB drives, for example. Zip disks, those probably aren't used as much either, but they were kind of like floppy disks, except they stored larger data. CD-ROMs, tapes, DVDs, USB drives, solid state drives, those are becoming more popular, and the number just seems to keep growing. There are external hard drives that you can use, but all those would be considered secondary storage. So any type of device that you would connect to your computer that can store stuff would be considered a secondary storage device. And when you store something in there, it stays there until you decide to delete it. Now, if we want to do anything meaningful in a program or do some type of useful task, we need to be able to have the computer read in data to do some types of computations and then be able to display the results of doing stuff with that data. Otherwise, you're just saying run a program and then you don't actually see the results of it, or if there's no input to go with it, you're not going to be able to do any meaningful computations. So we have devices that help us out with dealing with this input and output. So for devices that allow us to handle inputs, well, they're called input devices. So these are devices that allow us to bring in data and programs into computers. So these are a variety of different devices that involve some type of user interaction or anything that just serves as input to the machine. So for example, a keyboard would be considered an input device because you're typing stuff and the characters that you type actually get sent into memory, and then the CPU actually interprets those keystrokes to decide what you're actually doing with it. The mouse is an input device, so when you click on the mouse, you're interacting with your computer, so something happens when you do that click. Secondary storage devices would be an example. So if you have a program that's reading data from a file, maybe that file, well, not just maybe, but that file would be stored like on a USB drive or on a disk. Nowadays, even touch screens would be considered input devices. So if you, depending if you're dealing with like a smartphone or a tablet, if you touch the screen at a certain place, your computer interacts in a certain way depending on that interaction, but that would also be considered an input device. Now, the devices that the computer uses for displaying these results or even storing results are called output devices. So when your program is running and there are some outputs or some type of result, maybe you're displaying that or maybe you're storing that, but these would be considered output devices. So a couple of examples of these would include the monitor, so you can actually see the results of a particular program, the printer, so if you're writing up a paper and you want to print it off, you can write a program that does that. There are secondary storage devices, so if you store something in a different file and store that like on a USB drive or a hard drive or a disk or something, that would be an output device. But anything that involves displaying results or storing results would be considered an output device. And then here is a diagram of how we can visualize the layout of all these different components. So we can see that our CPU and main memory are grouped up together as one component. So we can think of that is basically the main part of our computer. Now there are other parts to the computer from a physical perspective. There's the motherboard, there are video cards, sound cards, network cards, fans, and all these different wires. So all that is part of the computer, but from a program and a processing perspective, the main parts of the computer are the CPU and the RAM. So we see that they interact with each other. We have these arrows that show how they interact. So with main memory, it sends either data or an instruction to the CPU. It does something and it sends it back to the main memory. And then we have our different devices that are connected to that component. So we see here, for example, that our input device, maybe it's like a keyboard, that gets sent into the computer. That's going to get stored to our main memory. Then we interact with that input with the CPU. If we do some result, that gets sent back to main memory. And then that can get sent to like an output device, for example. So maybe that's like a monitor, just to give an example. And then we have our secondary storage down here where we have arrows going both directions. So as we said before, a secondary storage device could be both an input device or an output device, where we could send like a file as input, for example, and then we could take that updated file and then store it back into our secondary storage device. But this is just how we can see these different components interacting with each other.